Coupled with the new operator is the delete operator. New operator is used to allocate memory and delete operator is used to free that allocated memory. Okay, so if your program reserves many chunks of memory using new, eventually all the available memory will be reserved and the system will crash. Okay, so if you are continuously reserving the memory using new, then ultimately you will eat up all the memory and eventually the system will crash because there is no memory available. Okay, so to ensure the safe and efficient use of memory, new is matched by corresponding delete operator that returns the memory to the operating system. So when you allocate memory using the new operator, you use this memory for a duration of time, and after that duration of time you do not need this memory anymore. So a good programming practice is to free up that memory using the delete operator. Okay, so that this memory becomes available for other uh, requirements. So in this program we allocated memory using the new operator, but we did not release this memory using the delete operator. But when this program ends, this memory is automatically released. Okay, but if you want to specifically delete this memory explicitly, then how to use the delete operator? Delete and then the pointer which is pointing to that memory. Okay, so P is pointing to the memory which has been allocated by the new operator. So when we write delete P, then that memory will be freed. Okay, so memory released. So first it has been allocated using the new operator and then it has been released using the delete operator. So now if we try to print the value of P, then let us see what is the output. So as the memory has been released, now P is pointing to some garbage value. Okay, so a very important point to understand here is that the memory has been released. The memory where this variable was stored, suppose it was stored at some address 1234. Okay, so P was pointing to address 1234. P is equal to 1234, which is the address of this memory which was allocated, and its value is 100. Okay, so its value is 100, and when we release this memory, then the location 1234 that will be freed. Okay, so the value placed there that will be deleted and that memory will be available for future use. Okay, but this pointer, we have not deleted this pointer. This pointer is still pointing to the same location 1234, and when we again try to print the value of P after freeing up the memory, then it is giving us a garbage value because that memory now contains some garbage value. Okay, and now let us try to see how to allocate memory to an array using the new operator. Okay, so uh, let us create another variable I here, and in the try block we will now allocate memory to an array. Okay, so this array will be of type integer. We will write new int, And now instead of writing the initial value inside the parenthesis, we will use the square brackets and we will write the size of the array. Okay, so what will happen in case of array? Memory will be allocated, new will allocate memory. It will allocate memory equal to the size of an integer. Suppose integer occupies 4 bytes, and that size will be multiplied by the number of elements you want in the array. So we want 5 elements because we are mentioning the size here. It is 5. Okay. So it will allocate memory equal to 5 integers. So memory for 5 integers equal to 20 bytes will be reserved here. Okay. And the base address of that chunk of memory will be returned, and that address will be stored in pointer P. Let us give some initial values here and see whether we are able to initialize when we are allocating the memory. Okay, and let us remove these statements also. Let us try to print the values of array. For int I is equal to 0, I less than 5, I plus plus, cout P I and ENDL. Let's run it. Yeah, 1, 2, 3, 4, 5. So we are allocating the memory to the array equal to 5 integers, equal to the size of 5 integers, and the base address will be returned to pointer P, and we are also initializing those values using the curly braces. Inside the curly braces we are mentioning the values to which we want to initialize those integers. So the first integer will be initialized to value 1, second to value 2, third to value 3, and so on. Okay, and here we are printing those values. And if you want to free that memory, we cannot simply write delete p as we did in the previous example. You want to delete the memory allocated to the whole array, so you will put the square braces here. Okay, so now it is okay. So now here we used the try and catch block to handle the exception when the system fails to allocate memory to the using the new operator. Okay, so another alternative to handle that exception is to use the no throw version of this new operator. In that case, we will not need these try and catch blocks. Okay, so let us see how to use that. I remove the try and catch blocks here. Okay, and here I am allocating memory using the new operator, and here after the new keyword we write no throw inside the parenthesis. So this will automatically handle the situation if the memory fails to be allocated to this pointer P. Okay, so if the memory has not been allocated to P, then P will be null. Okay, P will be a null pointer, and in that case what we will do, we will print some message. Suppose allocation failure, and simply we will exit from this program. Okay, so here I am writing return 1, means we will return from the main, and 1 means 0 means When we write return 0, it means the program has executed successfully, but here I am returning 1. It means there has been some problem while running the program. Okay, so let's run it. So it is also working fine. So you have two options. Either you can use the try and catch block for handling the allocation failure exception, or you can use the no throw version of new.